there's the question in the middle. It is the question here on page 39, question number 4. If we can just enlarge it a little bit more, and then you notice. Thank you very much. There we have it. It says that Marshall stands on a platform and kicks a soccer ball from 6 meters above the ground. That is now at position A. We also notice in this case that this ball is moving vertically upwards into the air with an initial velocity of 4 meters per second. So, okay, so I take note of that as I go on, I underline it, and the ball hits the ground, that is position D, after 1,6 seconds. So, I underline that as well. The motion of the ball is represented in the diagram below. Ignore the effects of air resistance. And then 4.1, calculate the maximum height, position B, the ball reaches above the ground. I'm going to shift it out, and then I'm going to show you how I write down all the pieces of information that I can get from the reading material. I'm going to read it one more time to make sure that I've got it clearly. And then I'm going to write down what I think are some of the main pieces of information that is given to me. Okay, here goes. First of all, I'm reading it aloud again. Marshall stands on a platform and kicks a soccer ball. So, let me just draw the platform quickly for you. There's the platform, and he kicks the soccer ball. Assume this is my soccer ball there, and this soccer ball goes, he kicks it upwards. So, at the top, that is my final velocity, and here is my initial velocity, and my initial velocity is 4 meters per second. So, I write it in, my initial velocity is 4 meters per second. Now, I think what I'm going to do straight away, even before I start, I'm going to choose my positive direction. I'm going to say upwards is positive, and I'm going to write it out here, take upwards as positive. I want to write it down because I'm working with vectors, and must I tell you why I'm writing it in red and why I immediately did that? Because I realized one thing, that this ball is moving upwards and gravity is downwards, and that's the time that I have to have a sign convection. When G is down and V is upwards, I have two vectors, they're in opposite directions, therefore I must choose one of them is positive, and I need to emphasize this while I'm busy with it. Can I just say again, when I notice that I have two or more vectors and they're in opposite directions, I am forced to choose one as a positive direction. Anyone, it doesn't matter. But here's the other trick. I then need to apply that sign convention. In other words, up is positive. I must use it in all these subsections of my question. How's that? What do I mean by that? If this is 4.1, then I must use the same sign convention in 4.2. Well, let's look at it immediately. I'm back to my whiteboard and see where I am now. So I know that that is upwards, it's plus 4. And I know that my final velocity is 0 because I'm now at the top, and we always know that the velocity is 0 at the top. And then of course, there's a last piece that I cannot forget, and that is learners tend to forget, and that is G. And then I forget about that, and 1, 2, 3 I find that I do not and must not forget that that is minus 9,8 because it is in the different direction to that one. So, there I have my pieces of information, and what am I supposed to find? Oh yes, I write it in green. The question was, what is the maximum height? Maximum height displacement, so that is delta y and that is the variable that I'm supposed to find. So how do I go about it? I now go to my data sheet and I find an appropriate one that contains these four. So I'm bringing the data sheet into your view now, and I looked at it and I see which one will have VI, VF final velocity G, and delta Y in it. And it looks like it is this equation here. This one here, that's right. That's the one with final velocity, initial velocity, and delta Y in it. So off I go very quickly. So I write it down. I then say in 4.1, I have the following. I write down that the final velocity squared is equal to the initial velocity squared plus 2 times G and then delta Y. And then I simply substitute from here. I simply substitute from there. So I write what is that one? Final velocity is 0. So it's 0 squared is equal to what is the initial velocity is 4 squared, and I then take 2 multiplied by, I keep the sign minus 9,8 downwards, and I multiply that by delta Y. And now you know how this works. I have one term here in which I have my unknown and I have another term there. So I first get rid of this one, the second term. So that I take that over, etc., etc. So I find that 2 minus 9,8 delta Y is equal to 4 squared is minus 16. So it's 16 which I take across, and then when I get my answer eventually and I use my calculator, which I'm not going to use today, I'm sure you are now well aware of how to use it, it would be 0,816, and it is displacement, so it is meters. But let me read the question very carefully, because I think there was a catch in that one. It says above the ground. Oh yes, and the height here was 6 meters. The height here from the ground to up there was 6 meters. That means I now have to write out the complete answer, and the complete answer would be maximum height, the maximum height above the ground would then be is equal to 0,816 plus 6 meters, which gives me 6,816 meters. And that is, please watch, learners, if I can get your attention for a moment. Please watch very carefully to read the question carefully. They said above the ground, not above the platform where he was standing. So they have to add the 6 meters to that. Okay, so that takes care of the first part of the question. Let me see what the second part of the question was very quickly. Where is our question? I've closed the book again. Okay, it was page 39, I think it was. Here we go. Question, second part of the question reads as follows. Calculate the time taken for the ball to reach maximum height. Calculate the time taken for the ball to reach the maximum height. Let's quickly see what pieces of information we have and how we're going to approach it. Let's go back to my whiteboard once again. Once again, I write on this side because I find it quite easy to do that. I write my initial velocity was 4, my final velocity was 0, and I know now the delta Y was 0,816, and I don't forget that G is minus 9,8, and then of course they asked me to calculate the time taken. Time taken is delta T. That is what I have to work out. So I look again, once again I look at my data sheet and I try to find one of the four equations which always have 4 unknowns in them. 1, 2, 3, 4 unknowns, 1, 2, 3, 4 unknowns in them, and I must have 3 pieces of information to answer the question. And the question is, this time I must find the time. Okay, so I look through them. What do I have? I go here to my corner and I see I have initial velocity, final velocity, I have gravitation, acceleration, and time. And I go to my data sheet, and that one doesn't have everything for me. I'll use this one here. Here I have final velocity, initial velocity, acceleration, and delta t. So I can use that one. Once again, remember, I have to write down, take up if you want to, as positive. And I underline that so that the person who marks the work can see my sign convention. And then I ask myself, what is that? And I copy it directly from my data sheet. I always copy it from here. I say Vf final velocity is equal to initial velocity plus g delta t. And then in this case, I can see my final velocity was 0, my initial velocity was 4, and I plus it, and g is minus 9,8. Please note that, and I have delta t. Once again, I am sitting with the same problem. I have 2 terms, one there and another one here, which is plus 4 by the way. I want to find that one, so I first get rid of the friend of it. This one I don't need, so that goes to the other side, and then I do the normal thing. Let me just go through this slowly with you so I can explain to those who don't know how I'm doing it. So I'm going to rewrite it, so then I'm going to say minus 9,8. Can you see I'm just writing everything on this side now? And I multiply it by delta t, and I take the 4 cross along, is minus 4, and then I take delta t, that is what I want. I divide by minus 9,8 this side, and I divide by 9,8 the other side, minus 9,8. So that cancels there. So I have delta t, and that answer should be 0,41, 0,41 seconds. Okay, that was the question. Please practice this with 2 terms. It will always be in a paper somewhere, so it is very important that you actually know how to go about it. Now, let us look at the next part of the question very quickly. The last part of this question, which is the third part of the question, I'm going to put it on here and see if we can all look at it once again on my whiteboard and see if we can actually notice the question. Okay, there it is once again. And it says, draw a sketch graph of position versus time graph for the motion of the ball from the moment it was kicked until it hits the ground. Use point A as the reference point. Wait a minute. Here's a few things I need to note. Let me read again. Draw a sketch graph of position versus time. I make a note for myself. I need to position versus time. That is what I need to do. And secondly, from the moment it was kicked until it hits the ground, use point A as the reference point or 0 point. Indicate all relevant position and time values at positions A, B, C, and D. Okay, let's talk about that for a minute and see what we can come up with. I must have a position time graph. That means in reality, it is a displacement time graph, but where the 0 point has been fixed. So let's quickly go and discuss what happened with the ball and then see how easy it is. What I normally do is, I normally ask the learners, please show me where the ball was at the beginning, 6 meters above the ground. Then show me the motion of the ball. And it went up there, and it came down, past the same height, that's what it was supposed to be, and it went right down to the 6 meters, and there it is now on the ground. So now I need to draw in my axis. Unfortunately, I don't have a ruler, but they say take position A, which I take it to be this point, and that is position B, and this is position C, and this is position D. They say take position A as the reference point. A reference point meaning the 0 point. So if I've got to draw in my axes, these are my axes, that's my y-axis, and here is point 0, 0, 0 for y and 0 for x. That means that is my x direction. So it's position time graph. So what do I write here? I got delta y on this side, and that is measured in meters. Okay. And then what do I have here? Position time graph. So this is my time graph, and that is measured in seconds. And now they say that I must fill in some of the details. Well, what do I know? How long did it take for the ball to reach its highest point? What was the time? 0.4 seconds. That means down there was 0.4 seconds. How far did it go up again? It was 0.8, let's say 82 meters. The same time it took to go from here to there is 0.41. So from there to there is 0.82. 0.82. That's right. What else do I know? I know that from where he was standing to the bottom, it was 6 meters. So if I come right across here, this is 6 meters. And what else do I know? They gave me a clue in the reading material. They said it took 1.6 seconds for it to complete its journey. Let me just double check. Yes, 1.6 seconds. So if I take this right up here to complete, it was 1.6 seconds. And there is the type of graph that they would like me to draw in the examination. Did you see, notice how I did it? I looked for the 0 position, for instance, and of course I then give them the convention and tell them that in this case, up is positive. I write there that upwards, up is positive so that they know about it. Okay, so let me summarize and ask you, what is it that we have really done today? First of all, we've spoken about frame of reference. There are definitions in your book, but the basic things I would like you to know that if you got to find the velocity or the vector of A relative to B, this is how we write it. There is A and there is B, and we put the road or a vantage point in between the two of them. Please go study this. It is also in your examination guidelines. It tells you exactly how to do it. The other important thing was the changing the direction of the vector. Vector A with relation to B, if we change BA around, it gets the opposite direction. In vertical projectile motion, the important things that I think I emphasize for you is please use signs, especially when the motions like gravity and velocity are in opposite directions. Use sign convention, choose one area as up or down. Then choose the correct equation of motion. You will always have 4 unknowns. You need to know 3. Don't forget about G, and G, the acceleration, gravitational acceleration, is constant at 9.8. Be careful, the sign of G always. And then lastly, I would like you to analyze, interpret graphs, and read on page 26 in your Telematic book about what the gradient means and what the area under a graph means. And that, as far as I'm concerned for today, is where we're ending.